Welcome to the video on prime numbers, and they're in chapter 6. There's a sample program that deals with prime numbers, and you really need to understand how to generate prime numbers. And in the meantime, you'll also learn more about methods and how to structure your code properly. Now, this is my project right here. This is the way I organized it. You can see I have a whole bunch of projects from previous semesters, but this is my primary project, and inside that project there's a package called Chapter 6, and in that Chapter 6 package is all the source code that has to do with Chapter 6. It's part of the textbook. You can download that. Now, in particular, we're going to take a look at this class right here, prime number method. And the prime number method is basically a main program that says, hey, the first 50 prime numbers are generated by this method right here, and here's the method that actually goes through and generates the prime numbers. Now, there's a lot wrong with this program. First off, why just stop at 50 numbers? Why limit the program at just 50 numbers? Wouldn't you like to know maybe the first 100 numbers, the first 130 numbers? Who knows? But keep the program general as possible. Why don't limit it to just 50? And this particular program right here, he says he's got a lot of comments that make no sense. You know what? Like when you see count plus plus, of course you're increasing the count. That's in my view not a good comment. Print the prime numbers in. Okay, fine, that's good. I think the code itself, if the names of the methods are properly picked, like isPrime is a good name for the method, because if I were to pass this method a number, it returns true or false whether the thing is prime. So you don't need to have a comment. So I'm not a big proponent of comments just for the sake of comments. I'm going to get rid of all these comments because the code looks better without them. And only when you need to remind yourself and the user or some other user of your code just what you're doing do you put comments in there. So look at this. Print the number, advanced and negative course. System.print. Sure. Of course you're printing things out. Okay, and keep that right there. So the program is smaller and sweet, and here we have isPrime here. We'll take a look at it. But before we take a look at the actual code, we're limiting ourselves to just 50 numbers, and once we run this code, the program stops. You really need to use the template. So we talked about the template in the previous video on greatest common factors, and what I'm going to do is bring it up again. And before I start coding this program, what I'm going to do is in my project, I'm going to create another package. Where's my package? Right here. Create another package here. Packages are a great way to organize your code. I'm going to call this prime numbers. Okay, packages generally begin with lowercase letters, so that's what I'm going to do here. Prime numbers. Finish it. And basically a package is nothing more than a directory. What I'm going to do for now is I have this template for projects code that I downloaded. I'm going to keep it around because you're going to use it all semester long. So I'm going to keep this and just copy that into my package. Let's do that. Okay, well, I moved it apparently. That's okay. That's all right. Come over here. We'll take a look at this. And the reason why there's an error there is you need a package statement. Because once you take one code that's found inside a package has to have a designation that says this code is part of the prime numbers package, and that error should go away. If I save it, okay, the error should go away. Here it is. Okay, I hit the wrong button there. Now, before I continue, what you're going to do is go through the class and prepare it, because this name of the class should describe what you're trying to do. What I'm trying to do with this class is do some analysis. So how about prime numbers analysis? Okay. Okay, that's fine. And why is there an error there? Because the name of the class, the public class, has to match the name of the file. Okay, so we can fix that very easily by coming here, rename the file to prime numbers class. We've done that. And if you're going to run this code, what you're going to do is it's going to welcome you with this name here. And obviously, you don't want that name. What you want is a prime numbers analysis. Of course, it's version 1.0 until we come up with something better. Continue prompt. That's good enough. You can keep that there. And the rest of this code we discussed, we're not going to talk about, okay? Because as far as we're concerned, we start our coding in the process method. Now, this is an example of a piece of comment that is necessary. It tells you start your logic coding in the process method, and I'm going to do that. Now, the process method is great. We have an open scanner, and we've got some arguments that may have come along in your command line, but I haven't done much with arguments there, so we're not going to talk about that too much. And this code is merely a sample. Okay, now here's where we start coding. Okay, we'll cut that out right there. Remember, you generally need to clear your keyboard for this thing to work. Start coding. Okay, we'll start coding right there, but I'll get rid of that. What I'm going to do is take the logic. Okay, your main method, basically let's copy this code, copy this. Whatever was in the main method in the textbook becomes part of the process method here. Okay, and then we're going to change this up a little bit by saying, well, we're not going to limit ourselves to just 50 numbers. What we're going to say is enter the number of primes to generate. And let me just delete this stuff over here. Get this out of here, right there. And I don't want a print line. I want my prompt on the same line as the numbers. And I'm going to say, well, integer n equals my open scanner, next int. Okay, I got that. And now we're going to have a method called print prime numbers, where instead of pressing 50, we're going to pass it n. And there's an error here because we never defined print prime numbers. Well, that's okay. Let me just copy this code. Let's put this code right in here. Copy that. Copy that. And I'm going to put it into my area there. Okay. Now, every so often, what you want to do is go. Let me just minimize this so you can see this. You can't minimize it. Okay, what I'm doing is I'm printing, I'm saying edit, no, actually source, where is it? Source format, I'm sorry, source format. I've selected source, then format, and what it does is it formats your code nicely. That's good. Oh, and by the way, before I even started this, remember the global section? Fill that information out. That's the very first thing. That's step 0 of your solution analysis. Fill this information out. We won't do that now. So let's take a look at this. This is a void method. Prime numbers is a void method. Void methods return nothing. Okay? They return nothing. If I try to say I try to store something, integer x equals, okay, that's wrong because print prime numbers is a void method. And if you try to do something, sys out, okay, sys out, oh, it's not doing it for me. Okay, system dot out print line. Now if I try to do something like this, print prime numbers, this is going to be wrong as well because what gets returned from this method is nothing, and you can't print nothing. Void means nothing, so process in itself is a void method. Okay, void methods basically are methods that just execute code. They just execute code, and you're not relying on any return values. So let's go back to what we had before. I particularly don't like void methods, okay, because you're not using a facility of the method that, let me go right here, okay. You're not using a facility of method that is returning something. Personally, what I'd like that method to do is return all the prime numbers, that the first nth prime numbers in terms of an array, but we don't know arrays yet, and we'll do that in another video. But this is basically the start, and all we're really doing is the number of primes is a local variable that gets assigned to the same value of n. Remember, pass by value. If I typed in 313 here, then 313 comes here, and I start off count. I'm counting the number of primes I'm generating. I start off, I didn't generate any prime numbers, so count is equal to 0. We start off with the number 2. Hey, is 0 less than, I don't know, 313? Fine. Okay, that's certainly true. If is prime is a number, if is prime number is prime, then we're going to process it. If it isn't prime, if this is false, you exit out. You're not going to do this processing. You go to the next possible number, 3. So 2, 3 would work. 4 is not going to be prime, so you're not going to process that number. And you're not going to count it. You're not going to print it out. So what do I mean by prime? What do I mean by processing? Well, if you encounter a prime number, you want to count it. Okay, and basically what we want to do is print these numbers nicely. Number of primes per line. I want 10 prime numbers per line, basically formatted nicely with this printf statement, so that we don't want to just see one number at a line. We want to see a whole bunch of numbers on a line. And you'll see what it looks like when we run it. But the idea here is, hey, we count it. 1, 2, 3. When count mod 10 is equal to 0, then we must have processed 10 numbers. Let's issue a carriage return. Let's issue a carriage return right there. Otherwise, don't issue a carriage return. Now that I look at it, you know what I think might be better? Is a better code is if I just move this up here. Okay, I do one nicely formatted number, okay, with no new line, and then at the end what I'm going to do is say, hey, if count mod 10 is equal to 0, then issue a nice print line. Okay, there's no need to duplicate that fancy printf statement right there, so I'm going to cancel that out, and I think that's all I'm going to do. Get rid of, what did I just do there? Okay. I just deleted everything. Edit, undo, typing. Okay, here's what I'm going to do. I'm going to get rid of this. Delete. I'm going to put my brace here. I'm good to go. I'm good to go. Now, certainly isPrime is the workhorse method. It's not defined. And before I encounter it, isPrime should return a Boolean, true or false, and should accept a number, an integer, because that's what number is, an integer. So if we take a look at the code, that I'm not going to really change too much, because his code is not that bad. Other than I'm going to remove comments, copy that. I'm going to take that isPrime and copy it into my program here. And then you know what I'm going to do is source format, because I got to have my code formatted nicely. And the fact that you use the word is here doesn't require this comment. Okay, doesn't require that. And basically what I'm doing is I'm saying, listen, I take in a number. All right, I start my divisors. See if you can find a number that divides evenly into number. Start with 2, start with 3, 4, 5. Okay? So if divisor is equal to 2, and I don't really like this, so I lied. I'm going to change this up a little bit. Oh, so basically, if the divisor isn't, if the divisor that you've initialized is less than, say, the number, check to see if you can divide evenly. If you could say yes, number mod divisor is equal to 0, then what I'm going to do is return false. Okay, now if you've checked every possible factor and divisor or whatever you want to call it, and nothing divided evenly, it must be true that it's prime. So let's get rid of this. Let's get rid of this. Oop, oop, oop. Get rid of that. And let's get rid of this. We don't need this. Now, it's this upper limit that I don't like. Okay? If you think about it a little bit, you only need to go up to the square root of the number. Okay? So think about 100, 101. Say 101. 101 is prime. 2 doesn't go into 101. 3 doesn't go into 101. See, what happens is 2 goes into 101 evenly, generating a 50. 2 and 50 are factors. 3 doesn't go into it. 4 generates another factor of 25. Eventually, you're going to get up to 100, go up to 10. There's no need to go beyond 10, because if you go beyond 10, you're testing numbers that that are implicitly known to go into the number evenly. So just go up to the square root of the number, and what I'm going to do is just say integer of that. Cast that to an integer. So 101 square root is going to be 10.111 or whatever. Okay, but I only want to go up to 10. So call it an integer, and I think that's better code right there. Let's run this thing. We did some major surgery on this program. Okay. Ooh, look at that. Welcome to the prime numbers analysis. Enter the number of primes to generate. 22 primes. Hit enter. Look at that. Ooh, I don't like it. Look at this. See, I output these numbers, but then the prompt is on that same line. We're going to have to fix that. But basically, you see 22 numbers there, and because let me hit enter. So it's basically functioning, and the idea here is listen. What we're going to do is we're going to issue a carriage return by just doing print line at the end of this entire process. That's the easiest way out. Okay. Run. Okay. Let's see. 22. That's better. Much better. Do I want to do this again? Yes. 50. That's nice. That's very, very good. Okay, so we're going to stop the video here, and we're going to go on to another video. I'm not sure what we're going to talk about there, but it'll be up soon. All right, we'll see you in the next video.